Hello guys, welcome back to lecture series on linear algebra. Already we have started lecture series guys based on the linear equation, solution of linear equation. Okay, so in our today's video guys, I'm gonna explain to you all a detailed understanding of non-homogeneous system. Okay, so along with we go for some of the example. Okay, so if you want to see similar points, you go and check in my playlist. Okay, so in our today's video guys, we are going to understand complete and detailed understanding for the solution. Okay, how it look like and how can we find. So today's lecture, it is completely devoted to straightforward calculations. Only we want the straightforward calculation for finding the solution of our equation. Finding the solution of equation means we have equation in a three variable x, y and z. Finding the solution means we have to find out the value for x, we have to find out the value for y, and we have to find out the value for z. Okay, so we want the value for x, y, z in our equation in a three variable. Okay, so we are having three equations. Okay, so we have to find out the solution of equation in a three variable. Okay, this one is a straightforward way. So in our next example, we go for using consistency and inconsistency of a matrix, and then we find the solution. Okay, today's solution, it is only the straightforward way for finding the solution. So you can solve this system by using Cramer's rule also, but this one is quite bigger. To get the solution for xyz, it will take a lot of time. Okay, so your task is that to find out the solution for linear equation in a three variable using Cramer's rule, and let me know the answer in my comment section. Okay, yes, so here in my today's session, I'll explain this one with a non-homogeneous system. Okay, so what is a non-homogeneous system? We are having non-homogeneous system x which is equal to b, and b which is equal to z, and z not equal, z which is equal to non-homogeneous. Okay, not equal to null matrix. Okay, this one is a non-homogeneous element. That means we are having x which is equal to b, and b which is a z, and z is a null matrix. Okay, that one we call the system of non-homogeneous equation. Okay, yes, this one is a non-homogeneous system. So we try convert this matrix in the non-homogeneous system. Okay, so first of all, let me write the matrix A. Matrix A is a coefficient matrix. Coefficient matrix in our system. So coefficient matrix means write down the coefficient of x, coefficient of y, coefficient of z. So here all the coefficient of x, all the coefficient of y, all the coefficient of z. Okay, yes, coefficient of x is 1, coefficient of y 3, z is a 2. Okay, again this one complete. Coefficient of x is a 3, y is a -2, and z is a 5. Coefficient of x is a 2, y is a -3, z is a 6. Okay, x, y, z, these are the coefficient of x, y, z. Okay, yes, so this is the matrix I got it here. Okay, so after that we want the x. So how can we write the x? X is an unknown variable. What are the unknown variable? X, y, z. X, y, z are the unknown variable here. X, y, z, these three are the unknown variables. Okay, yes, and after that right hand side we write as the b. Okay, which is a not null matrix. Okay, yes, 6, 5, 7, 6, 5, 7. Make sure that while writing the matrix, be careful. So after getting the non-homogeneous system, you want our given system back. Okay, so if you're going to multiply this matrix, you will get this system back again. So if you want to cross verify, do it for one of the row. 1 into x plus 3 into y plus 2 into z, which is equal to 6. That means x plus 3y plus 2z, which is equal to 6. See that, x plus 3y plus 2z, which is equal to 6. So you can do it similarly for the other elements and verify these three equations are coming or not. Okay, yes, so that's it here for the so conversion of our given system of a linear equation into the non-homogeneous form. Okay, so our task is that to find out the inverse of a matrix, solution of a unknowns. Okay, x, y, z. Okay, so we are taking this form into the consideration. Okay, ax which is equal to b for finding the solution. There are so many other ways guys, you can use inversion, reduction like methods. Okay, but we are not going for this one. So I want the solution, that means try to get into the some simplest form. Okay, so what you do, you multiply a inverse to the both side, a inverse into a, which is the identity. Okay, so identity to x, we write only the x. Okay, we do not write x identity there. Okay, and a inverse into b. Okay, so if you multiply to the left side, then a into a inverse is a identity into x is a x. Okay, so a inverse it will go here also. Okay, a inverse into b. So how this step it is coming, so you have to apply a inverse into a inverse into x, a inverse into a. Okay, a inverse into a into x, which is equal to a inverse into b. So I applied a inverse to the left side. Okay, here left and here as well. So a into a inverse identity into x, it is only x. Okay, so a inverse b it is remaining here. Okay, so see that you want the value for x, means you want the value for xyz, so that you have to find out the a inverse and you have to find out the value of b. But in actual we are having the value of b which is present here. Okay, so value of b it is here, value of x is xyz. Our only task is to find out the inverse of a matrix A. Replace this value here, multiply with the b and get straightforward value for xyz. Okay, yes. So guys, see that for if you want the inverse, there are so many other ways that you can find out the inverse. I already explained Gauss-Jordan method. You can use the short trick also, or you can go with the minor cofactor method like adjoint of matrix method. Okay, for finding the inverse. So we are having the formula for a inverse is a 1 upon determinant of a into adjoint of a. Okay, this is the standard formula that you can use to find out the solution. But make sure that inverse only exists whenever matrix is a non-singular and matrix determinant need to be a non-zero. So let's find out the determinant of matrix A. Okay, so finding the determinant of matrix, I knew it, you all are familiar with all the concept. So if you want the similar concept, go and check in my playlist. You will get to see that how to find the inverse, how to find the determinant, all the concept available there. Okay, so after finding the determinant of this matrix, okay, you're supposed to find the determinant of the matrix. Okay, so after finding the determinant of this matrix, you will get the minus 31. Okay, which is non-zero. You have to find out the determinant. I'm not finding it, it is very easy. Okay, do it for your homework. Okay, determinant of a is minus 31, and comment me in my comment section how many of you got the determinant minus 31. Reply me minus 31 into the comment section. Okay, determinant of a is minus 31, which is a non-zero. Okay, yes. So if determinant of a is a non-zero, that means a matrix A is a non-singular. Matrix A is a non-singular. Okay, and if matrix A is a non-singular, then only we can define the inverse, or you can take short trick 1 upon determinant of A. So 1 upon 0, it goes to infinity. Okay, so we cannot define any number by 0. Okay, because 0 number, it doesn't exist, it is not the natural number. So we write this one as infinity. Okay, 1 upon 0 is infinity, so that number does not exist. Okay, so in this case we do not want determinant as a 0, but it is a non-zero over here. Okay, yes. So we have to find out the adjoint of matrix A, multiply to the 1 minus 1 upon 31. And how to find the adjoint of A, I already explained in my last lecture. Okay, adjoint and cofactor method. Adjoint means transpose of a cofactor matrix. Okay, and cofactor matrix means you have to find out the cofactor matrix in like a Cij is equal to minus 1 raised to I plus j into Mij. Okay, there you have to find out the minor. Okay, this is the entire process I already explained in my last lecture, guys. Okay, so I'm writing directly the A inverse is a 1 upon determinant of A, which is a minus 31. Okay, into adjoint of A. Okay, so adjoint of A we are writing here. Okay, I already found the answer, that's why I'm writing. Okay, so your task is that to find out the value. Okay, find out the value for adjoint of A. This one is your homework. Okay, do it for the adjoint of A. If you don't know how to find, go to my last lecture. Okay, you will get the complete process for finding the adjoint of a matrix. Okay, yes. So after finding the adjoint, you will get the values 3 minus 24, 3 minus 24, 19. After that, minus 8, 2, 1, and minus 5, 9, minus 5, 9, minus 11. Okay, this one is the entire A inverse. Okay, so that it is very easy, guys, not that difficult. It is very easy solution for finding the it is very easy to find the inverse. Okay, yes. So our task is that to replace that A inverse here and a value of a B here. Okay, then you will get the value for x. Okay, x which is equal to, we are having A inverse into B. Okay, so value for x is a xyz, we want the xyz. Okay, What is the value for A inverse? Minus 1 upon 31. Okay, always remember that minus 1 upon 31 which is equal to 1 upon minus 31 which is equal to minus 1 upon 31. All these are equal. Okay, all these sides are equal, so don't get confused. So xyz is equal to minus 1 upon 31. We are writing the A inverse. Okay, A inverse, value for A inverse into 3 minus 24 19 minus 8 2 1 minus 5 9 minus 11. Okay, this one is our entire A inverse, guys. Okay, multiplied by the matrix B. What is the matrix B? 6 5 7. Okay, so multiply that matrix B here, 6 5 7. Okay, so keep minus 1 upon 31 as it is. Okay, multiply these two matrix. Okay, so how to multiply? This multiplied by this plus this multiplied by this plus this multiplied by this, you will get this element. Okay, so after calculation you will get the value for it is 31. Okay, after this multiplied by this plus this multiplied by this plus this multiplied by this, okay, you will get the minus 31. And after that this multiplied by this plus this multiplied by this plus this multiplied by this. Okay, so you will get the minus 62. Okay, this is the entire value for x, y, z. Okay, yes. So right now we want this one into also simpler form. Okay, we divide minus 1 by 31 to the entire column matrix. Okay, so what we will get, the minus 131 upon 31 multiplied by 31, it is a minus 1. Minus 1 upon 31 multiplied by minus 31, it is 1. Minus 1 upon 31 multiplied by minus 62. Okay, so we'll get the 2. Okay, this one. So x, y, z is equal to minus 1 1 2. Okay, so what we write, x, y, z which is equal to column matrix minus 1 1 2. Okay, so when we write two matrices are equal, okay, when the two matrices are equal, whenever their corresponding elements are equal or their corresponding element should be equal. Okay, so corresponding element means x which is equal to minus 1, y which is equal to 1, and z which is equal to 2. Okay, z which is equal to 2. This is the corresponding element that they are equal. Okay, yes. So once corresponding element equal, we write the solution for our given system of a linear equation. Okay, this one is a non-homogeneous system, guys. I hope you all have understood how to find the solution for non-homogeneous system. It is only the